Assalamualaikum and greeting to all the viewers and participants of Research and Innovative Technology Competition I-RITEC. Today I would like to introduce to you guys a fundamental research entitled Vibration-Based Piezoelectric Energy Generated from Bicycle. First, let me introduce our team member of this project. Starting with myself, Muhammad Arif bin Abu Bakar, third year student at UTHM, TS Dr. FARAHIYAH binti Mustafa as senior lecturer at UTHM, Ahmad FAID Imran bin Nasri and Muhammad Amin bin Ibrahim, which are also third year student at UTHM, and last but not least, Encik Omar bin Abu Hassan, senior lecturer at UTHM. We will begin this presentation with project background. So, piezoelectric energy harvesting is an important component of renewable energy, converting unused mechanical energy into eco-friendly power, boosting sustainability. So, the utilization of piezoelectric material of energy harvesting offer an alternative rather than relying solely on conventional energy source. So piezoelectric sensors are divided into several modules, including the ceramic module, which are frequent practice, and piezoelectric thin film, which are rarely being used. Unlike ceramic module that rely on pressure, thin film derive energy from vibration, and this project will focusing on piezoelectric thin film. So the aim of study is to explore using piezoelectric thin film sensor in bicycle to convert unused mechanical energy into electrical power, which then can be applied for portable phone charging. Move on to the next slide, which is objective. Here we have three objectives to be achieved in this project, including to develop suitable circuit diagram of piezoelectric film sensor that can harvest energy from vibration. Next is to investigate the performance of integrate piezoelectric transducer with bicycle to efficiently convert the wasted energy, which is mechanical energy, into electrical energy. And lastly is to test the potential of an application as portable phone charger that can be directly charged. Next is the list component that being used to carry out this project. Here we are using piezoelectric thin film sensor, diode 1N4007, capacitor, voltage regulator LM3170, resistor and also USB port. Next is the circuit diagram of our project. So we are develop this circuit diagram to get an idea on how does the output will become. Starting with piezoelectric thin film, which is output is in AC voltage, it will be converted into DC voltage through bridge rectifier. The capacitor is to smooth the voltage output from the bridge circuit and also to store the output. Move on to the next stage, which is voltage regulator circuit. So we are using LM3170 as our voltage regulator so that the output voltage can be adjusted. And lastly, the output of the circuit is USB port, which is for charging. So the diode before the USB port is fashioned to avoid voltage from flowing back to the voltage regulator. So we move on to the next slide, which is step of developing the product. So after circuit diagram has been confirmed and functioned, all the components will be soldered on the board. Voltage for both circuit, which are bridge rectifier and voltage regulator circuit, are being taken by using two multimeter. And this is how the wiring circuit look like. And lastly, we are remeasuring the voltage value to double confirm it. And this is the final setup look like when we attach to the bicycle. So move on to the next slide, which is result and finding. So for the testing, we are using three pieces of piezoelectric thin film sensor, and the maximum speed of bicycle tire that can be measured is 300 rpm. So the purpose of this finding is to observe voltage output for each circuit, which are after bridge rectifier and voltage regulator when the speed of bicycle is being varied. So the results show that the faster speed of a bicycle, the higher voltage output can be produced. So the result also show that the voltage output after voltage regulator circuit is lower than the voltage after bridge rectifier. In theoretical, voltage for both circuits should be same or slightly same. However, when we being applied in real application, the result does not align with the theory. But the higher voltage output may be obtained if another set of circuit is connected in series with the existing circuit. Next is the novelty and uniqueness. So this project is novel and unique because it came up with a new way to harvest electrical energy from a moving bicycle tire. This idea is also unique since it is easy to use and fit well with the bicycle. Next, user can obtain a supplementary power source for charging their electrical device. And last but not least, the piezoelectric energy harvesting method can also be used for other things than bicycle, such as motorcycle, scooter, since it is flexible and similar in concept. So next is usefulness and application, and also benefit to mankind and society. So the energy harvested from the rotating bicycle tire can serve as supplementary power source, not only limited to the charging mobile phone, but it also can be power source to GPS device, bike light, and other device with USB connector. The product is also perfect for generating power on the go since it is lightweight and compact. Users not only produce electricity through cycling but also engage with exercise, which make for a healthier way of life. So by getting more people to ride bike, carbon pollution from transport can go down and people will be more active. This can improve public health and also make the air in the cities cleaner. And lastly, people can use less traditional power source, which is especially helpful in remote place or when they're doing things outside. So next slide is market and commercial potential. So this project can be commercialized due to several possibilities, including collaboration with cycling manufacturer. So cycling manufacturer might consider this technology as a functional addition to be integrated with their bicycle. This project also has commercial potential due to the rising demand for simple charging option in the current generation of smartphone and portable electronic device. In today's society, people need to charge their device frequently even while on the move. And lastly, this project enhances its commercial potential since cities, communities and business are actively encouraging and supporting environmentally conscious project and product. And last but not least, environmental friendliness and sustainability. So begin with renewable energy source. Piezoelectric energy harvesting depend on the conversion of mechanical vibration such as rotation of bicycle tire into electrical energy, making it a renewable energy source. This project helped fully utilizing the vibration that would probably go to waste. This was done by capturing and converting unused mechanical energy into energy that is useful. So next is the project also prove its environmental friendliness by reduce the carbon footprint. By utilizing the clean and green energy from piezoelectric source, we contribute to a cleaner and healthier environment for future generation. And lastly, this technology use less energy and have less effect on the environment over throughout the duration of its lifespan. So piezoelectric energy harvesting system often work efficiently and do not require much power from external source. So I hope you guys will gain something new from this presentation, and that's all from me. Thank you.